Problem number 11. An escalator can carry passengers up a vertical distance of 10 meters in 30 seconds. A mischievous person of mass 50 kg walks down the up escalator so that they stay in place with respect to the building. If the child does this for 30 seconds, the total work the child performs on the escalator in the frame of the building is next one. Solution for problem number 11. The average power is F average multiplied by Vy, where F average equal negative mg is the average force exerted by the child on the escalator, and Vy is the vertical velocity of the point of contact. Other words, one or both of the child's shoes when they are touching the escalator. This velocity is precisely the speed of the escalator, 10 over 30 meters per second. The result is this one. Notice that the work done by the child on the escalator is the negative of the work done by escalator on the child, which has the same value mgh as it would have if the child had remained stationary. So that was answer B, and that was a solution for problem number 11. Задача номер 12. A platform just out horizontally from the edge of the building. If the platform is modeled as a uniform metal rod, which one of the following statements about the tensile and the compressive stress is correct? Solution for problem number 12. There must be tensive and compressive forces at the top and the bottom of the rod respectively to balance the torque on the rod from gravity. Ultimately, these forces come from the wall the rod is attached to. That's answer C. There is a horizontal tension in the top of the rod and the compression in the bottom. And that was a solution for problem number 12. Problem number 13. A uniform disk of mass m and radius r is attached at its edge to a flexible pivot on the ceiling. It is given a small displacement perpendicular to the plane of the disk, so that it begins to oscillate perpendicular to the plane of the disk. What is the period of oscillation? The moment of inertia of a disk about the axis going through its center and perpendicular to the plane is I disk equal 1/2 mr square. Solution for problem number 13. If we orient this disk in the direction of perpendicular to plane of disk as axis z, so it means that IZ through the center of disk will be 1/2 mr square. Due to perpendicular axis theorem, we have IZ equal IX plus IY, where IX and IY are moment of inertia around axis of rotation in the plane of disk, which is going through center of disk. And due to symmetry, Ix equal Iy equal 1/4 mr square. Now, due to parallel axis theorem, we have moment of inertia of disk through the edge of this disk, as on the picture, equal 5/4 mr square. And now we can make equation for small oscillation. If we make a small displacement for angle theta, we have torque created by a force of gravity equal negative mgr sine theta, or for small theta that will be negative mgr theta. And now we can write equation that I alpha equal tau, and finally we have angular acceleration proportional to angular displacement with negative sign. It means that this equation describes small oscillations where this coefficient, that's omega square. We have angular frequency equal this expression, and finally period equal to I multiplied by square root from 5r over g, which is answer B, and that was solution for problem number 13. Problem number 14. A large block of mass 5 kg is moving to the right at a velocity of 10 meters per second. Spaced out every meter are smaller, initially stationary block of mass 1 kg. All collisions are perfectly inelastic. Neglecting friction, how far will the large block travel before its velocity has decreased to below 3 meters per second? Solution for problem number 14. Here we have momentum conservation. It means that full momentum equal to mass of the large block multiplied by its initial speed, which is 50 kg multiplied by meter per second. It means that total momentum is conserved. It means that it's equal to m2 v2, where v2 equal 3 meters per second. It means that m2 equal 16.7 kg. Finally, we see that when we have mass of small blocks is 12 kilograms, our big block speed became first time below 3 meters per second. It means that answer is 12 meters, which is the answer C, and that was solution for problem number 14.